The next graph we're going to be looking at reads y is equal to a half cos of x. Now you will remember that the sine graph we dealt with was y is equal to 2 sine of x, which doubled. Now we're looking at a half of cos of x. 0 degrees. Cos of 0 is equal to 1. A half times 1 is a half. Cos of 90 degrees is 0. 0 times a half is 0. Cos of 180 degrees is negative 1. Negative 1 times a half is negative a half. 0, positive a half. And in the negative axis, it's still going to go 0, negative a half, 0, positive a half. That means that this graph is going to look a bit like this. Notice that all we've done is we've sort of halved the amplitude and halved the trough in our wave to get the graph y is equal to a half cos of x. The final graph we're looking at is the graph y is equal to cos of x minus 30 degrees. X minus 30 degrees means that we're taking our graph and we're shifting it to the right 30 degrees. So instead of the peak being at 0 degrees, it's now going to be at 30 degrees. Instead of it dropping at 90, it's going to drop at 120. Instead of it being a trough or negative 1 at 180, it's going to be that at 210. That is going to be at 300 degrees, and it's going to peak at 390, but we're not going to go till there. We are going to go from there though. And so our graph is going to be our normal cos graph, except it's been shifted 30 degrees to the right. So it's going to peak over there, and it's going to turn and start coming back down already. And that is the graph cos of x minus 30 degrees. We are now going to look at the tan of x graph. We are only going to look at one transformation, tan of x minus 45 degrees. Now all that this means is that our tan graph is going to be moving 45 degrees to the right. That means that each of our asymptotes as well will move 45 degrees to the right, and each graph will follow those asymptotes, will also move 45 degrees to the right. So it will still be the standard tan graph, except now it will be moved 45 degrees to the right. I did take a bit of a lazy way out, in an untidy way, but that's the graph tan of x minus 45 degrees. You can also do transformations with the tan graph, for example tan of 2x or tan of x, but because this graph stretches to infinity in both the positive and the negative y-axis directions, it won't really change the shape of the graph. It might just pull it a little bit tighter in or loosen up a bit, but essentially we're still going to be looking at the same tan of x graph. I hope that you found those basic sketches quite easy. We are now going to look at sketching multiple graphs on the same set of axes. I want you to have a go at the following. Press pause on your DVD player, and when you return, we'll go through it together. We are now going to look at the graphs of y is equal to sine of 2x and y is equal to cos of x minus 30 degrees drawn on the same set of axes. I'm going to start off with my set of axes. I'm going to cheat, which I don't want you to do. I want you to draw it properly in your workbook. Well, you can't cheat like I can. And I'm going to take my graph, sine of 2x, and I'm just going to put this on my axis. The next graph I'm going to draw on is the graph that I did earlier of y is equal to x, y is equal to cos of x minus 30 degrees, which will go over there. I'll just rewrite that. And the blue graph is the graph y is equal to cos of x minus 30 degrees. Except the blue graph, we've now called it g of x, or the cos graph rather, and the sine graph, we've called it f of x. We are now going to look for the points of intersection, or rather the points where these two graphs meet. And I'm going to draw that in black. There's 1 point over there, 2 points, 3, 4, 5, 6. Now my graph is highly inaccurate. Both my graphs are fairly inaccurate. If you draw it properly, you will find that there are 2 points of intersection over there, because you're going to find the red graph goes slightly above the blue graph, or the sine graph goes slightly above the blue graph. That means that there are 1, 2, 3, 4, 5, 6, 7, 8 points of intersection between these two graphs. We are now going to look at how to calculate those points of intersection. Draw this graph in your workbook. I trust that you found that quite easy. Now in your workbook, you will notice that right under the space that I left for you to sketch the graphs, there is a section titled Interpretation. We are now going to look at that, how to interpret of a trigonometric graph. I want you to have a go at the interpretations that are set out in the workbook. I want you to have a go at the interpretations that are asked in the workbook. Press pause on your DVD player, and when you return, we'll go through it together. We are now going to look at our graph, and we are going to find the points of intersection. Unfortunately, it's very difficult to do that accurately by inspection. We are going to have to do that by calculation. Now look at your graph carefully. Wouldn't the points of intersection be when f of x is equal to g of x? That means now f of x we know is the sine graph sine of 2x. G of x is the graph cos of x minus 30 degrees. When f of x is equal to g of x, to get our corresponding x values, we need to solve this mathematically. What's the problem with this? One is a sine and one is cos. As you saw in the previous exercise, it was an easy one to solve. Keep this as sine of 2x is equal to sine of 90 degrees minus x minus 30 degrees